Hey Geometries, this is Mr. Bloom doing the Chapter 5 review. This is Lessons 5-1 section. Okay, what are the three pairs of parallel segments in triangle DEF? Three pairs of parallel segments. Remember, MN and DE is parallel because this is a mid-segment triangle. M and N and O are all midpoints. So because it's a mid-segment, MN is parallel to DE. And remember, because these are midpoints, this is a mid-segment, and MO is parallel to FE. Okay, my last one here, I have ON parallel to DF. So I got ON is parallel to DF. So keep that in mind. What are the three pairs of parallel segments in triangle DEF? Now in triangle RST here, G, H, and K are midpoints. These are all midpoints, okay? And we are looking at RS being 28. We are looking at GH being 20. We are looking at RH being 22. So that's 22. So they've got some stuff here. Since I know RS is 28, it is opposite its mid-segment, which is HK. So that's half the value. But let's find out which ones we're supposed to find. KH, let's do that one first. So if I talk about KH, KH is half the value of RS, and RS is 28. So half of 28 is 14. So KH is 14. Okay, the next one is ST. ST is this length. ST is twice as big as GH. So if I take 2 times my GH, I will get ST. I know that GH is 20. So I know that ST is 40. My last one is GK. GK, remember, is 2 times GK is going to equal, now you got to be careful, 2 times GK is going to be equal to RT. Okay, now they have broken RT up into 2 parts. Now I can look at this and go, well, you know, 2 times RT, or 2 times RH is RT, excuse me. Okay, so there's a couple ways I can think about this, and it's just how I think about them that'll help me out. Now, 2 times RT, all right, so not 2 times RT, excuse me, I want to talk about 2 times RH, because we've got that going on. 2 times RH is actually RT, because remember, this is also 22. Or I could just look at this as GK is 22. Okay, because RH goes in and we've got that covered. Now, what's the distance across the river? You know, I've got this mid-segment triangle set up, and how I know it is this is 55 and this is 55. And they've got this. This is 92. So if I know 2 times my distance across the river, I'm going to call that x, 2 times x is equal to 92, I can divide by 2 and find out that x is 46. So it's 46, and I'm assuming feet, so 46 feet across the river. Okay, and problem 4, when I'm getting this done, I'm looking at setting these up. Now these are all mid-segment triangles because they're all midpoints here because of the way the triangles are marked. What I want to do is show you how I set them up, so if I come across variables in the mid-segment and the side it's parallel to, you can still use this method. 2 times x is equal to 34. If I divide by 2, x is 17. Remember, 2 times x is 41. If I divide by 2, x is 20.5, because this is the mid-segment. This is the mid-segment. 2 times 10 is equal to 5x. So 20 is equal to 5x, and dividing in x is 4. So make sure we know that this is 20 and I've checked my work. Okay. Make sure you're comfortable with going through these. Now let's talk about angle bisector here. In 11, according to the figure, how far is A from segment CD and from segment CB? Remember, that distance is a perpendicular distance to these points. I want you to think about them as floor, and I'm measuring the height from D to A. Okay, how far is A from CD, or CB for that matter? And they both happen to be the same. They are 15 units. Now, how is ray CA, okay, so I'm looking at ray CA, that's this ray right here, ray CA. How is ray CA related to angle CDB? And angle CDB, DCB. How is ray CA related to angle DCB? Excuse me, that's not DCB. This is DCB. Now I'm happier with my answer. Okay, ray CA is the angle bisector of CDB. So I can say ray CA is, or I should say bisects, because it cuts angle DCB in half. So ray CA bisects angle DCB. Okay, ray CA bisects angle ray CA bisects angle DCB. Now, so that, because they are bisectors, I know that 2x is equal to 3x minus 29. And negative x is equal to negative 29, so x is 29 here. So I was able to find that right there. Now they're asking me to find the measure of angle ACD. ACD is this one, so 2 times x, maybe I should put in that that is the measure of ACD. The measure of ACD is equal to 2 and times 2x, which I pop that back in. So 2 times 29 is 58 degrees. Now my other one here is ACB. The measure of angle ACB is, and remember, x is also 29. So 3x minus 29, and I plug in 29 and I calculate that with my calculator and I find out it is also 58 degrees. Now my last thing here is they are talking about the measure of DAC. So let's go back to our diagram. I'll get rid of these things I've marked up already. And we're looking at this angle DAC. So if I go from D to A to C, and I go from B to A to C, I am actually looking at this right angle, and these are both 58. So just by third angle theorem, I know they have to be congruent. So the measures have to be the same, and they have to be, remember the triangle makes up 180, so if I'm looking at the measure of DAC, I can find it this way. So that's 148 plus the measure of angle DAC, and 180 minus 148 gives me a 32 degrees. Now, what's really interesting, there's a couple ways of doing this, but keep in mind those are the same angle. So not only is DAC 32 degrees, but so is the measure of angle BAC. Okay, and that's page 1 of our review. Now on page 2, we're looking at what is MN. Now this is perpendicular bisector theorem. I have something that's perpendicular, it's cutting this segment in half. The distance back, remember that's perpendicular, the distance back from the endpoints on the perpendicular bisector is always the same. So I know 6x minus 1 and 3x plus 8 are the same. Now after I set this up, I'm in algebra land. Okay, so x is 3. So it's 9 plus 8, which is 17. Okay, and x is 3. I'm checking both. 6 times 3 is 18 minus 1 is 17 again. So I've checked them. Now, When I'm looking at a problem like this in 13 and I'm working with angle bisectors, be aware that I'm looking at the endpoints here, and the distance back from the endpoints, it's got to be the same if this is an angle bisector. And how do I know? This is a right angle. These are marked as congruent, and this is my angle bisector. So this is a perpendicular, not an angle bisector, my perpendicular bisector of that segment, MO. So those are equal. So I know that 3x plus 20 is equal to 5x. So 20 is equal to 2x, and x is 10. So this is 50 on this side, and over here this is also 50. Now in 14, what is the center of the circle that you can circumscribe about a triangle with vertices 0, 4, 0, 0, and 8, 0? Now, if I sketch this real quick, if I go 0, 0, 0, 4, 1, 2, 3, 4, okay, that's my A. This is my B, and I got 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. That's my 8, 0. Okay, that's C. I meant to put in C. If I look at this way, remember when I'm talking about my circumcenter is located on the midpoint there. So I'm going to take my A0, my 0 plus 8 divided by 2, and my 4 plus 0 divided by 2. My circumcenter is found the midpoint of the hypotenuse of this triangle. So the midpoint happens to be 4, 2. And if I go out here 1, 2, 3, 4, 1, 2, that's where it's at. So the circumcenter is on the midpoint of the hypotenuse, okay, in a right triangle, and that is at 4, 2. Now in 15, we're looking at GB is 8x minus 7. GB is 8x minus 7, and CGD is 5x plus 8. Now, keep in mind, these are angle bisectors. Angle bisectors make incenter. The incenter is the same distance back, perpendicular distance back to the sides, is the same. So I know that these are congruent because that's incenter. So this is incenter made by angle bisectors. Let me write that a little better. So I've got incenter, okay, made by angle bisectors. Distance back to the sides is the same. That's why I can do what I'm going to do. And I'm going to say 8x minus 7 is equal to 5x plus 8. Okay, so 3x minus 7 is equal to 8, 3x equals 15, and x is 5. Now, x is 5. I can plop that back into either one of these. That's 40 minus 7, which is 33, or that's going to be 25 plus 8, which is also 33. They're both 33s. And GB, GD, and GF are all the same value. So I know GF here is 33. Now on this next two, I'm going to graph them, okay, and I'm looking for circumcenter. Okay, so I've got 1, 3, 1, 1, 2, 3, that's my A, 4, 1, 2, 3, 4, 1, 2, 3, that's my B, A and B, and at 4, 2, 1, 2, boy, that's a pretty tight little triangle here, I got C. So that's what I've got for my triangle. The circumcenter is on the midpoint of the hypotenuse of a right triangle. So 1 plus 4 divided by 2. Okay, I'm using 1 and 4 because it's AC. Midpoint of AC is what I'm looking for. I've got 3 plus 2 divided by 2. Okay, so I've got 5, so I got 2.5 and 2.5. Well, that's kind of convenient. Let's see if that worked. 2.5 and 2.5. So my point would be about right there. So it's the circumcenter, okay, is the midpoint of my right triangle. Let's do that in 17. So 2, negative 3, 1, 2, 3 is A. Negative 4, 1, 2, 3, 4, 1, 2, 3 is B. And then I got negative 4, negative 7, 4, 5, 6, 7 is C. I have a triangle and I'm looking for a circumcenter, and the midpoint of the hypotenuse of a right triangle is the circumcenter. So again, I'm going to take 2 plus -4 divided by 2, and I'm going to take -3 plus -7 divided by 2. And that point should be -1 and -5. That's my circumcenter right here, -1, -5, 1, 2, 3, 4, 5 of that triangle. Now that's where my circumcenter is located. So we got that there. Now this next one looks really weird, but I'm looking for the angle, the angle bisector of the angle of a triangle for point, and I'm supposed to name the point of concurrency. It's the point of concurrency that the angle bisectors will make. So, and that's what that says if I flip it upside down and read it in a mirror. But if I also look at these are angle bisectors here. So I'm looking for the point where the angle bisectors come across, and that's in center. So I'm looking for the in center. So I'm finding in center here, and let me change colors. So really this is find in center, and that's where the angle bisectors come together. Okay, so the in center here for 18 is N, the in center here for 19 is F, and the in center here for 20 is looking like it is P. Okay, now the last three here on this page, what we're doing, okay, is talking about, is AB a median and altitude perpendicular bisector or none of these? So if I look at AB, this is going from the midpoint of the side to the vertex. Okay, that is a median. Okay, in 22, I'm looking at this being perpendicular going to the vertex, and that is an altitude. And in 23, I look at this as this the midpoint because of these markings, and it's perpendicular, and it does not have to go through the vertex if it's a perpendicular bisector. It does if it's an altitude or a median. So this is the perpendicular bisector. Okay, and that's page 1 and 2 of your review. I hope things are going well. If you have any questions, please locate your nearest geometry teacher and ask it. Talk to you soon.